Unit Operation Classroom, GATE 2023, question 27. An isothermal jacketed CSTR, which is this one. Uh, this is jacket. And this could be any process, something like, let's say, fatty oil hydrogenation process. This is operating at 150 degrees Celsius, 150 degrees Celsius. So the feed to this one comes at 150 degrees Celsius is shown in the diagram. The cold feed entering the system at 30 degrees centigrade is preheated to a temperature T less than 150 degrees Celsius. So this is my cold feed, and this is entering 30 degrees Celsius. Now the product which comes out from the heat exchanger contains a lot of heat energy. So it is is a concept in economics, that we recover some amount of that heat before the feed goes to the reactor. And for that, we use a preheater. So this is my preheater, which exchanges heat, where the cold feed exchanges heat with the product which is coming out at 150 degrees Celsius. And then, of course, after some cooling, this product goes out for further processing, and the feed is heated to a slightly higher temperature, which is at 3 degrees Celsius. The preheated feed is further heated to 150 degrees Celsius, causing using the utility heater HX2. So this is my utility heater. And so whatever this temperature T degrees Celsius, to that we heat it up to 150 degrees Celsius before it enters the CSTR. The mass flow rate and the heat capacity are assuming to be same for all process streams. So what's coming here, the mass flow rate, and it remains the same here. And the overall heat transfer coefficient is independent of temperature. So whatever the overall heat transfer coefficient here, we are assuming that to be independent of temperature. Which one of the following statements is correct action to take if it is desired to increase the value of T? That's the idea. We have to increase the value of T. To increase the value of both heat transfer area HX1, if we increase this heat area of heat exchanger HX1, of course, the temperature will increase. If the temperature increases here, then of course here the heat duty, let's say this utility heater is here, that this is heated by some kind of a MP steam. Okay, so the heat duty, if this temperature increases, since this is a constant temperature, 150 degrees Celsius, so this heat duty will decrease. So increase in both heat transfer HX1 and heat duty HX2. So this is not true. So this is false. B is decrease both heat transfer area HX1 and heat duty of HX2. First of all, if we decrease the value of heat transfer area HX1, this temperature will decrease. But our purpose is to increase the value of T. So this option is also not true. Increase the heat transfer area of HX1. Again, if we increase the heat transfer area of HX1, the temperature will increase, which is in line with the question. And then, of course, we have to decrease the heat duty. We can decrease the heat duty here, so that since this temperature is increased, we have to put in less heat here. So the heat duty of this one decreases to maintain the same constant temperature, 150 degrees Celsius. So this is, of course, is a true option. And number D, again, in decrease the heat transfer area HX1. If we decrease the heat transfer of HX1, the temperature will decrease, which is again not true. Okay. So the correct option is C, which is the correct option.